There'll be chasing.
Chasing, you say?
If you go to, like, the
Speaking of chasing, all right, cool. For the people traveling, if they want to see it, there it is. Oh, my badge is messed up. All right, cool. Okay, couple things. I just went through and checked that note problem. If you are traveling, I didn't give you a grade and you're exempt. Cool. This is where we left off. Now, we had to factor it. Pretty common, and we're going to see it today as well, that we make it less than or equal to 0, or whatever the case is. I made this comment to somebody, when I actually do these problems, when I write this statement, and I physically do write this even on my own work, because it's an easy thing to mess up, and if you mess it up, you get the whole problem wrong at the end. What I normally really and truly write is I'll do something like this. Less than, is this going to be open or closed? It's going to be open, and then less than 0 means negative or positive. I usually write something like that, where it'd be a solid bullet if it were a or equal to, and then I would write a plus if it were positive. That's usually the notation I use, but this is a good thing to remember. Okay, as I came around, people who didn't get it completely done, like it happens, but I noticed you had these numbers on your number line. Okay, just to check. On our number line, as we're looking at it, I use the number 0. And this is always going to be the one that I use if I have the opportunity. When I plug in 0 to factored form, I get negative times a positive times a negative. Guarantee that's going to be a positive number. Now, I don't care what the number is. I'm just getting a positive. And then I use all multiplicity, all of it, just to get these next ones. Could we have picked a test point between these? We could have. We could have tested an actual value in each interval. What would you have chosen here? I would probably pick 2. Over here, 5 is a natural choice, but I would have picked 10 just to make sure that I don't have to really think about it and worry about it. I would have picked negative 10 over here. Okay, so when we go through, notice before I draw the lines or the actual graph of this thing, if you can get to this point, the rest of it's super duper easy. At the beginning of the problem, we made this comment, or I did, and I hope you did. This means negative. Okay. Can you see intervals on this graph for which it spits out a negative value? Everything from negative infinity up until here, or from -4 and everything smaller if you want to change the language. I also see that this interval right here is negative, so I'll open circle it, I'll fill that whole interval, and I'll open circle. Okay, couple pieces of advice, and we're going to see it play out today, I'm sure. If it's an asymptote, even if it's or equal to, open or close circle, you think? If it's a vertical asymptote, do we ever touch it? So since we never touch it, open. Every single asymptote will be open. Okay, if you can get this, the rest of it's super chill. Always left to right if we're doing intervals. 2 issues that I saw with stuff. If you have all these signs worked out, this interval starts from negative infinity, which I can't touch, and it goes right until it gets to which value, or close to which value. So check it out. Here's negative infinity to -4 in my interval notation. The parentheses indicate that I don't touch it. I then union this. It's a U without the tail. I pick back up at 3/2 and I go to 4. Okay, this notation I think most of the time you guys consider easier. This one I might prefer, but I'm really impartial. This means less than -4, or it could be greater than 3/2, which I've written a compound inequality. So x is greater than 3/2 while simultaneously being less than 4. Cool. Feel all right? Okay. Feel bad? Maybe that's a better question. Okay, so let's look at these. We're jumping in, and I promise this will tie back together. You guys were struggling with this, which that's okay. I don't think you really will. But I gave you another example that I asked you to work because it's going to seem easier. 1/5 plus what was it? A little louder. 2/3? Okay. Right now, I can't add them. How come? Man, how would you find the common denominator? You multiply them. So, looking at this, important kind of piece. We need a common denominator. It doesn't have to be the least common. but it could be. So looking at this, we could call it the LCD if you want to, or I just recognize, and I am, there's no want. I'm going to call it the LCD. Anybody think of a number smaller than 15 that both of those go into? Now, if I asked you to calculate out a least common denominator, you may or may not remember how to do it. If we have two terms, we have the least common denominator, and I'm going to do it, of which numbers are our denominators? 5 and 3. Can either of those numbers be factored further? So give me a word for that. Both of those are prime. Since they're both prime, the least common multiple is just their product. Now, notice, I did say least common multiple. I don't want to confuse you guys with language here. The least common denominator is simply the least common multiple of the denominators. They're the same thing. LCM of the denominator is called the least common denominator. Okay, now looking at this, if we want to actually add these, I'm going to keep it white for now. This becomes 1/5, but what do I want the denominator to be eventually? I want it to be 15. And what would I have to multiply by to get it to be 15? 3, but if I do a 3 in the denominator, the only thing I can actually multiply by is a clever choice of what number? 1, so it's 3/3. Okay? And I know that you guys probably don't have to show all this work. Somebody might, and that's okay. But I am stressing this work for a purpose. 2/3 needs a what in the denominator? Good. It has a 3 already, but it needs its 5. But again, it's a choice of 1. Okay. If we go one step further, I think we're about done. And I'm going to take the liberty of skipping one step, and I want to see if you guys can tell me whether this is allowed. I know that both denominators are going to be 15. Do you agree that if we wanted to show one single step, that's really what just happened? Okay, and then it's 13/15. Okay. Quick check. Did anybody show more work than me just now? I don't know how you would. There's only one step that I skipped in the entire process. This stuff, you don't have to broadcast it out here, but like looking at it, yep, I can do this, or I do struggle with this. Either one's fine, but I need some sort of indication. Okay, so looking at it, this idea of making our common denominator is going to happen here. And I promise that this is going to immediately click into our inequalities, but let's just dive in. If I want to look at this one, we're trying to find the least common denominator between two right now. There's only two denominators. One of them is what? X minus 3, and I'm going to put it in parentheses intentionally, and x. Those are the only two. Can either of these be factored further? So it tells me then that the least common denominator, and I'm not actually going to distribute, but I think it's just going to be x times x minus 3. And I'm not distributing for very intentionally. Are you guys cool with that? It's the exact same thing that just happened here, but it's uglier. Okay, so let's just see what happens. I'm going to leave some blank space next to each expression, just so we can make sure we get our LCD. This is x squared plus 1 over x minus 3. I'm going to leave some blank space, plus 2 over x. And there's some blank space just naturally next to it. Now, we have found our LCD. This has part of it. What's it missing, though? This has the x minus 3, but it needs the... And I can only ever actually multiply by what? By 1, or a choice of... you're right. You're both right, just in different ways. What is this one missing? So it has an x already. We have that knocked out on this one. What does it need, though, for the LCD? I'm going to rewrite that. X minus 3, absolutely. So I'm just going to rewrite this so it's not ugly. And we need to multiply this one by a clever choice of 1 that gets us an x minus 3 in the denominator. So it's going to be x minus 3. In each of these cases, I've multiplied by 1. Nothing has changed. Do we have a common denominator at this point? Looks like it, right? It's x minus 3 in that. Cool. So we'll just keep trucking then. I didn't put parentheses around this. Are there parentheses around this? there are. X cubed plus x is what we get when we distribute here. And I'm not going to write two different fractions. Because I know they're going to shove together, because I've assured it will, I'm just going to say plus, and let's distribute this one. 2x minus 6. And then all of this is over what then? X minus 3 is a part of it. X times x minus 3. Notice, I still haven't distributed it. If I were just adding them, I might, but we're going to see that we won't typically. Okay, last little step. Are there any like terms? So we get x cubed plus 3x minus 6 all over this. Now, it's a little bit or a lot of it, depending on your point of view. It's more involved. But that process is exactly the same as the process that you learned 6th, 5th, 4th. I don't know when you learned this. But they're the same process. That is an important thing to recognize. Okay, we are going to be doing these. And we're going to add one little piece to it. Before we do any parts of this whole expression that anybody looked at and went, ooh, I don't really get it. Or what parts of this were you struggling with?
So you just multiply each side by, or not each side, but like each thing you're adding by the denominator of the denominator?
So sort of. In this case, there's only two. I'm just going to say missing parts of the common denominator.
What do you mean?
So like this, I know the common denominator is x times x minus 3. If this has an x minus 3, then the only thing I'm missing is an x. But we'll see here in a minute, is it possible that there was a third term that had something like this? Like maybe there was another fraction, and you don't have to change your problem, but maybe I had this instead. So now my denominator needs an x minus 3, it needs an x, and it needs an x plus 4. So when I look at this, I would say, oh, I have an x minus 3, but I'm missing an x and an x plus 4. So I would multiply by both of them. Okay, great question. Cool. All right. Let's continue on from yesterday then. Sweet. So we did how many yesterday? 3? Okay. Now, the same ideas are going to keep coming in. We're going to do one more, at least probably two more, actually, of the polynomial variety. So I'm not going to name this example yet, and we'll see why I'm not naming it initially here in just a minute. I want you guys to warm up with what we did yesterday without one that's too crazy. And let's check it out. I want us to find this inequality. X squared plus 6x plus 9. And I want to know, when is this thing less than 0? Once you get it, check with me. I'm going to use a little bit of editing magic up here, and I'm going to put a couple more up here. So there's 3 total, but they're all quadratics, which should factor fairly quickly. B and C will be on the board in just a moment. All right, B and C are up there. I'm going to give you guys a second. Whoa, that was weird. You guys are welcome and encouraged to chat these out with your neighbors. I'm going to give you a head start. I will check answers as you get them. Cool. If you're watching this video on the road, go ahead and pause the video. Try to work through these. Once you have solutions for all 3, resume, and the video will start playing again in 3, 2, 1. So when we go through here, what we wind up seeing on this first problem is there is no solution. Okay, I use a shorthand here. Alternatively, because our solutions are big sets of numbers, typically, like yesterday when we wrote, oh, it's all infinitely many of these numbers in these inequalities, it is common that you can draw a set of numbers that's empty. Literally called the empty set. This indicates that nope, no answer, because check it out, there's nothing in there. The last option is this thing, which these two mean for our purposes the same thing. This one right here with the curly brackets is called the empty set. This one people refer to as the null set, N-U-L-L. They mean the same thing. Cool. Now, going through here, this is the first time this has happened. These, I believe all of these, are unusual solutions. That's a weird thing that can happen, but it can happen. Okay. Questions? Is your factoring getting better? Cool. How does B factor? X plus 2 times x plus 2. And if I do that, check it out, I have a root of multiplicity 2 at x equals negative 2. Everybody good with that? Now, the other thing, I should have changed color. This thing, less than or equal to 0, it's going to be solid. And less than or equal to 0 still means negative with the understanding or 0. So let's throw these bad boys on a number line and see what shakes out. The only number is negative 2. I'm going to pick 0 every time. 0 plus 0 plus 4 is positive. It's positive over here. Uh-oh. Something's different about this problem. Because it's like almost seems like the exact same thing here, but it's not. Why? JV, we made eye contact multiple times in the last like 10 seconds. What do you think is different? Yeah, the inequality. Am I allowed to be 0 here? And is there any place that I know for a fact that my function is 0? And negative 2, because give me another word for root. 0. Cool. Check it out. My graph can exist this time, and that's it. Now, the answer here, Fern, I like yours. And I was this close to calling you by your brother's name just now, but look at that self-control. I like your answer. It's not really correct, but I would give it to you. The set of all the numbers, it's not infinitely large. What's the only number that's in our solution? Like this set had nothing in here. There's only one number that works here. What is it? Check it out. It's a set only containing negative 2. If you wanted this in like really formal set builder, the set of x such that x equals negative 2. And then, Fern, I wouldn't encourage you to put this places, but I think it's an interesting idea. You called this the interval negative 2 to negative 2. My issue is that I don't think that's really an interval, but I agree with you logically. Cool. Another weird answer, but doable. Okay. Do we need to do the factoring and stuff on C, or can we just talk about the answers? It'll take me 2 seconds. How's it factor? It's x minus 1 squared. These were all perfect square trinomials. Cool. X minus 1 squared equals 0. This means closed point and positive. So let's check it. It is x minus 1 squared. Cool. What are the roots? Or root, if you would rather. X equals 1, and it touches and turns, right? Okay. So here we go. Or equal to 0. Let's do our number line. Only one number is going to get a dash on this line, and it's at 1. What would you pick as your test point? 0 is a good choice, whoever quietly said it. When I plug in a 0, 0 minus 0 plus 1 is positive. Over here, it's positive, because I know it's going to be with multiplicity. And is 0 included on this one? So I know that my graph starts here. If it goes left, is it positive? If it goes right, is it positive? So what numbers did we just write? Holy, all real of them. Okay, this answer is the one that I prefer, Blackboard R. Let's write it as an interval. How far to the left does this go? Negative infinity. How far to the right?
How come this one's aligned with the other one's not?
So because notice we needed it to be negative here. And when I get to this point, is it negative on this interval?
No.
Is it negative on this interval?
No.
Is it negative at this point?
Yeah.
Careful, is 0 negative?
Isn't that negative too?
So I'm not looking at the x values, I'm looking at what the function spits out. So I know that if I were to plug in a 0, it spits out a positive value. Yep.
Yeah.
Now this one, because we're looking at positive or 0, when I make this, I say, oh, it's positive, everything to the left, everything to the right. And because it's or equal to, we also include that point.
Okay.
Make sense?
For right now, yeah.
Okay. And we'll see it again. Awesome. Factoring stuff obviously becomes more and more important. Let's jump in. We're going to do a rational inequality now. And we'll see how many we need to do together. We're going to do at least one together. And then I would like to give you guys some time to work, but we'll see how this first one goes. Cool. You want to write a quick haiku for me? Yeah, you're good. Cool. We won't do haikus yet. Not a whole lot of interest there. Breaking my heart, guys. 575. Yeah, we'll do it at the end. Okay. Here we go. We are going to look at this next section. Nothing changes, except we now are going to deal with rational functions. So I'm going to use my shorthand. I'm going to talk about rational inequalities. And we're just going to beat this into our brains here real quickly. I don't even know what we named the first section. Does anybody recall? Nonlinear inequalities? Polynomial. Cool. So we looked at polynomial inequalities, and now we're looking at rational inequalities, which are just a fraction with polynomials on the top and bottom. Okay. Most important comment out of all this. A rational function may change signs, and I'm going to say may only change signs at, I'm going to put a colon here because it's such an important idea. If you, and I'm going to let you guys catch up because that's a really bad habit of mine. We have a rational function, which means we now get fractions and stuff, which is pretty cool. When can a function change from positive to negative? One place is the roots, and then the other place is the what? Be more specific, because we've seen 3 different types of asymptotes. Good. We can do it at roots, which I'll just put this here. You do not have to. But that's zeros, x-intercepts, solutions, or vertical asymptotes. Now, I'm not going to write it because I know we already wrote it down in some fashion. But real quickly, we're going to sneak in one more. I don't think it's going to happen on our stuff. There really is one more place it can happen. Do you guys recall? It could be a hole, which isn't an asymptote. It's not really a root. It's just a hole in our function. Okay. Beyond that, to find roots of a rational function, all you have to do is find the zeros of which part? Numerator. To find the vertical asymptotes, it's the zeros of the denominator. Numerator roots, denominator asymptotes. Cool. Let's dig in. We're just going to use this, and it turns out we already have every tool possible. I'm just going to ask this to solve. And we're going to do one together. I'm going to get my calculator, and we're going to do, just kidding, we'll just pick every single one of you. I bet I can make this 9, 10 questions. Let's check it out. I want to know, when is it the case that x minus 2 divided by x minus 3, when is this greater than or equal to negative 3? This looks like a different problem. No different. Everything is exactly the same, except now we get one new key number that we're going to have to consider. We're going to have to be a little bit fancy, though. Initially, when we look at this, anybody remember what the negative 3 product property tells us? Of course not, because it doesn't exist. That's not a real thing. We use a which product property? When you factor, you're trying to find stuff that multiplies to be what in the end? Let me rephrase that. When you factor to solve an equation, you're setting it equal to what in the end? 0, and you're making sure that their products are always 0. not negative 3. Now, greater than or equal to negative 3 is ugly. Is there a better option? 0 would be nice here. Now, before if you want to add it, you can. Before I would add it, I would make a little note here. This number, negative 3, is not written as a fraction right now, but is it really a fraction? What's the denominator that this is over? 1. So before I do any of this, and nope, I lied, we'll do it this way first. I'm going to make it so it's 0 first. That's just going to make everything look nicer. How do you move this 3 over? You add it, and then this is going to look ugly for a second. It's going to look really ugly I'll leave it here, that's fine. I'm going to leave a blank space though, an awkward gap. Okay, right off the bat, we are at the exact same spot that we had been. Greater than or equal to, open or closed? So I'll just make this note here, it's closed, and greater than or equal to 0 means positive. Closed, positive. So I know when I get to my number line, that's what I'm looking for. Now, we have to be careful because it's only closed at which point? Zeros or asymptotes? You can't give me a number yet. Zeros. It'll always be open at the asymptotes. Now, this expression is kind of ugly. I cannot add them yet. However, we can do a little bit of thinking. This one works out nicely. I need, or want at least, the least common denominator between, what's one of my denominators? So I heard both of them just now. One of them is x minus 3 here. And what's the denominator on this? 1. Can you guys tell me the least common denominator or the least common multiple of these numbers? It's just x minus 3 times 1 is just x minus 3. Okay, notice I didn't leave a blank space next to this one because what's already in the denominator? X minus 3. I would prefer to just do the work here. Would you like me to go one more line though so it looks like we do this sequentially in your notes? Okay. Gosh, man, check this out. Technology. Cool. All right. What do I need this denominator to be? So I can put it over 1. So it has a 1 in it already, but it's missing an x minus 3. If I multiply the bottom of this by x minus 3, I must also multiply the numerator, or the top, by x minus 3. Questions, concerns, issues at this point?
That makes it make sense.
Good.
Yeah.
Make dollars?
Maybe.
Did you catch that or no? Bring your glove tomorrow.
Alright.
Gosh, the guy's on fire. Okay. So if you didn't catch it, he said it makes sense, and I said, oh, it makes dollars because a lot of cents makes a dollar. And then I asked him if he caught it, and he said no. So I told him to bring his glove, like a baseball glove, so he could catch my jokes. All right. Cool. Now, here's my time saver thing. They're both going to have the same denominator because that's what we just did. What is the same denominator they're going to have? They both get an x minus 3. Now, this expression, did we have to multiply this left one by anything? Like, it was just multiplied by 1 over 1 if you want to think about it. It just stays x minus 2. Let's go ahead and distribute this. Plus, what's this going to give me? Try again. 3x. How about this one? Minus 9, and it's still all greater than or equal to 0. You could write equals 0 if you really want. I'm fine with this one. This one's a little bit nicer. Okay, we're going to clean up one step, and I think I'll do it right here. I wish I had room to do it underneath, but I won't have enough to finish it. How many total x terms then in the numerator? Are you sure? So let me rephrase this. What's the coefficient when I combine my like terms? There. Because you're right, there are 2 x terms. I get it. Minus how many? Minus 11 all over x minus 3 still, right? And we are looking for where this is greater than or equal to 0. Again, if you want to change it to equals, I'm fine with it. Man, I feel like I might have asked this before. Mickey, can you tell me one place a rational function can change from positive to negative? It can change it to zeros. Cool. Huggins, the other place.
The asymptote.
The what sort of asymptote?
Vertical.
The vertical asymptote. Now, check it out. I'm going to include scratch work. Only do this scratch work if you need to show it. If you can do this in your head, I'm fine with it. How do you find the roots of a rational function? Set what equal to 0? What's that? So if I'm looking, when is a fraction 0? When which part is 0? So let's set the numerator equal to 0. So I'm going to write this out. This is n of x, my numerator, equal to 0. And we know that the numerator is 4x minus 11. And we're setting that equal to 0. I'm going to add 11, and I'm going to divide by 4. My root, my singular one root, happens at 11/4, or 2.75. Okay, it crosses here. I know it's going to cross here. And furthermore, or equal to, I know it's going to be solid. Sorry, say it again. Yep, because I would add 11, and I would have 4x equals 11, and then I would divide by 4. Okay, where are the vertical asymptotes, or put more simply, the denominator equal to 0? If x minus 3 is equal to 0, we can solve that and find the vertical asymptotes happen at x equals 3. If you need a reminder, this is okay to do. Here's a bullet. Here's an open point to tell me, look, I will use it and I won't. Out of all this information, we're looking for where it's positive in the end. How many numbers am I going to put on my number line right now? 2. My key numbers are only these 2. Key numbers. And let's do that. The most important part of this is we need to make sure that they're in order. So which one of these is further left? So here's 11/4. That's the one that gets a dash. Here is 3. And we have to make sure we write stuff. I'm going to write that a little nicer. You have to be clear when you write stuff down, because 11/4 is the one that gets this point, because it's my root. This one, no matter what happens, is open because it's my asymptote. All right, so I can use the root pretty easily. I can't use multiplicity across the asymptote, so I'll have to get one more test point. But let's check it. Give me a value of x less than this. 0 is a good choice. Now, when I plug in 0 into this, 4 times 0 minus 11 is a negative 11, over 0 minus 3 is a negative 3. I have negative 11 over negative 3. What sort of number is that? Positive right here. Everywhere to the left it will be positive. Now, if you love the idea of multiplicity because it's a huge time saver, use it. If you don't, that's okay. You need to pick a number between 2.75 and 3. I don't really want to pick it. I don't really want to. What do I guarantee it's going to be? How do you know that? The fact that that root showed up an odd number of times. Huggins.
Why is the, I know you're past this, but
No,
why
you're good.
is the 3 open?
Because we can never, ever, ever touch the asymptote, which means this close point indicates I can touch this, I can include it. I can never touch this.
Because it would make it undefined.
Yep, exactly. Yep, 100% that. Awesome. Can I use multiplicity here? I think it's going to be positive, but that's nothing but I think it is. Give me a number to pick. 4 works. Let's see, 44 minus 11 is positive. Divided by 4 minus 3 is positive. It is positive. We were looking for where this thing is greater than or equal to 0 from the get-go. Are there places where it's positive? Okay, the first one. I'm going to put my pencil down here. Do I move left or right for positive? To the left. Forever. It never stops. The next place that I put my pencil down is on this one. Does it move right or left to be positive? To the right. We are like 90% of the way there at this point. 99% of the way there. Do you guys prefer interval or set builder notation? The squiggly brackets or the parentheses and stuff? You prefer the fancy one?
It's cute.
It is cute, indeed. Very mindful, very demure. Cool. Everybody's, I would guess, that surprised me. Most people prefer interval. Write me set builder. I'll write the interval.
I don't like set building.
That's why I'm making you guys write it. So start with the curly bracket.
Those
and it's
lines.
X such that.
Those lines are weird.
The curly ones?
No, the one that goes in between X.
Oh, the inequalities or X? It's just a vertical bar.
Right.
It means such that. It is weird. So let's see.
Edge.
Wait,
Hey.
what are two words?
Cool. Awesome. Good change on that.
What are two words?
The set of X such that with, and I'm going to scribble on mine, all these numbers, there's an inequality that relates them. All these numbers X that can be plugged in left of that are less than or equal to what? Okay, cool. There's the first half. Or, which if you guys want it, you're probably not going to love it. The word or is that. Okay. Or, explain this inequality to me. Greater than, not 4, be careful. 3. We used 4 as our test. 3 is the number that's actually on our number line. Not or equal to because it's an asymptote. We can't touch it. Cool. This is a little bit more challenging algebraically. Conceptually, though, does it feel any different than the stuff that we've been doing for like the last week? There's a reason that I do the sketches. It makes this section super duper easy when we get to it. Cool. Would you like to do another one, or you want the 5 minutes for you?
I'll take it.
Which one? Because I give you 2 options.
5 minutes.
Okay. Anybody want an extra one? Okay. Well, those 5 minutes, I have a suggestion for how you spend them.
I could if you guys ever do that.
I showed you the wrong
I did it. Oh.
This is what I would like you. I'm not going to make you. Like, that was a good solid lesson. Not going to make you do this, but a couple things that I want you to be aware of. Tomorrow, y'all are going to do a team test. Cool. Like, legit team test. It's not going to be just a practice thing. It'll be a test that we'll do, let's see, 2 groups of 3 and a group of 4, or 5 groups of 2. Probably the 3, 3, and 4. That seems like the most easy to go. Okay. With everything.
We want to
Nobody wants me. Rude. Cool. These 4 problems need to be done. The team test. I'm debating if I want to let you use your notes or not. Probably need to. Okay. Just so you guys know, and I can add this in here now. The way, and this is going to disappear for like 2 seconds, but I'll put it back in there. Just so you guys can see what's happening. This time, we are at a point where I think it's going to be valuable to do this. Here we go. Tomorrow, Chapter 2, team test. Now, we have or have not done a real formal team test in here? Okay. You need to finish tomorrow in class. So you should study tonight. Just so you know, like, even with a notebook, I would encourage you to study. Because if all your time's doing that, I'm taking them at the end of the hour. And more than that, I'm picking one random person from your groups to grade. So everybody has to have it. You have to be able to discuss them, go through it. Okay, let's see. 2-3 is the weekend, which means 11-4. Review team test is what's coming Monday. And I will make a note card with you. Okay, this time we'll do it together. I debated if I wanted to just give you guys a note card, but I think we would all benefit from making one. Okay, which means on the 5th, we get what? Chapter 2 test. All right, and then we're out of the chapters that last like a month at a time. Cool. Sean, do me a favor. Go get your computer, do your SAT ticket. If you're doing it, because I see that thing's still on there. Did you do your SAT ticket yet? Okay. We'll scratch that then. Sweet. Why did I leave space here? Cool. All right. Awesome. I'm open to suggestions. I have some ideas. Something will get more buy-in than that. You probably don't have enough time to start your homework, but you have enough time to write it. If you want to get started on note card, I can hook you up.
No, I could grab it.
Oh, look at that. We got 5 more subscribers.
Yes.
Talking with some other students. Just so you guys are aware, they're doing essentially the same stuff as us, just with lower level, not going much as far as we do with it. In Algebra 2 right now, they're doing like standard form, which completing the square and getting to a times x minus h plus k, all that was in this chapter. So, homework due tomorrow, just so you're aware. I'm going to make you guys stick around for about 40 more seconds. Cool.